Hi everyone, this video is about a case study of Laplace transform, and to be specific, we will look at an RL circuit. So here we have a circuit with a switch, a resistor R, an inductor L, and a voltage source V. Now assuming your R is 6 ohm, L is 3 millihenry, and your source is DC 12 volt. Basically, you're being asked to solve the current of the circuit, which is to find the IT. Now, in order to do this, you are being given a formula for RL circuit, which is R multiplied with the current itself, IT, plus with the inductance, di dt, is equivalent to the voltage, which is V. So the first step is that we need to substitute the values in the given variables. So R here is 6 multiplied with IT plus with 3 milli, which is 0.003 di dt, or I prime t, is equivalent to V, which is 12. Next, we perform the Laplace transform on the both sides of the equation. So Laplace of 6it, or the current, plus with the Laplace of the inductance, which is 0.003, multiply with di dt, or I prime t here, equivalent to Laplace 12. So this, based on the table, is equivalent to 6is plus 0.003 in bracket SIS minus with the initial current itself at time 0, equivalent to 12 over S. Now the initial current we usually assume as null, so we can cancel that off and bring IS outside, multiply with 6 plus 0.003 S, equivalent to 12 over S. So now we can basically solve the current in the Laplace partial domain as equivalent to 12 over S multiplied with 1 over 6 plus 0.003 S. Okay, so we have done the first part, which is to derive the current in the Laplace domain. So the next step is basically to inverse transform this in order to derive the current in the time domain. Now before that, let's just normalize this into simpler form. So it becomes 1 over S multiply with, now the whole thing here we divide by 0.003, so we get 4000 divided by 2000 plus S. Alright, now if we look here, 1 over S is familiar. It implies Laplace transform of integrals, whereas 2000 plus S here reminds us of the first shifting theory of Laplace transform itself, where A equivalent to negative 2000, So here's the fun part. I'm going to go very slow here. So our current IT is equivalent to the integral, which is integrated from 0 to tau, because we have 1 over S on top there. So integration of 4000 multiplied with exponential to the power of negative 2000t, and don't forget your dt here. So your results here will be the whole thing in bracket 4000 exponential to the power of negative 2000t, and let's not forget over negative 2000, and it should be varying from our limits, which is 0 to tau. So next we can basically cancel here, negative 2000 with 4000 becomes negative 2, and so our answer here will be negative 2 exponential to the power of negative 2000 tau, okay, plus with 2 itself, okay, when we substitute t equivalent to 0, so that becomes plus 2. So that's it guys for this video. I hope you understand it. All the best and thank you.